So hello everyone, I hope everyone is doing well and good. So today we are going to learn another new sorting algorithm. Now before starting with that, now whenever we had to sort our shoes of different sizes, or whenever we have to sort the different jars at our storeroom, depending upon the size of it, then again whenever our teachers would have to sort our marks for finding the rank, how would they give us the rank, how they would sort the marks depending upon the ranks, and such many more activities. What was the sorting algorithm that they were applying there? What were the sorting algorithms which we apply while sorting the shoes or jars at our home? So at that time we were applying the selection sort algorithm. So today we are going to learn about selection sort, and let's see how we can implement it in C language. So here you can see that suppose we have this array of elements. It has 6 elements, and the index of the entire array is 0, 1, 2, 3, 4, and 5. It starts from the first one and it goes to the last one. So what we are going to do here, we will have two iterators here. One will be I and the other one will be j. Now I will be pointing out at the first element of every sub-array every time. It will start from 0 and it will go to n minus 1. Now why it will be going from 0 to n minus 1? Now n here means the last index 5. It will only go up to 4. So let's say n is the length. So it will be better if we write it as, if L is the length here, then we can say here that it will be going from L to L minus 2. Similarly, the j, it will be starting from I plus 1 every time. Okay, whatever be the value for I, it will be starting from the next one and it will go up to L minus 1. So let's see how it is going to work. First, whatever be the element, here we will have another variable which will be storing the index of the minimum element at every iteration. So here we have minimum index. Okay, now here minimum index will be the element where whatever is being pointed out by I. So here at the first iteration, the value of I is equal to 0, so min index will be here equal to 0. So it is storing 5 here. Okay, done. Now we have to iterate through the entire array and we have to find where is the minimum element. First we have 5 here, then we will check 10, no it is not, then 3, it is smaller than 5, so we will change this to 2 because 2 is the index here. Similarly, is 8 greater than 3? Yes it is. Is 4 greater than 3? Yes it is. Is 2 greater than 3? No it is not. So now it will be changing to 5 here because we have the minimum element at the index 5 here. So now what we are going to do, we are going to swap the values at the index, at the minimum index and at the I index. Okay, so after swapping these values, this is going to look here as 2, 10, 3, 8, 4 and 5. So here what we can see, 2 is the minimum element and it is at the perfect position in the array. So right now after this one set of operations, this will be called as first pass. Okay, this will be called here as first pass. Now again we will be repeating the same thing from 10 to 5 here. So now the value of I, it will be changing to 1 in the next iteration here. So again this minimum, it will be equal to I. So what is the value for I here? It is 1. So minimum index here, it changes to 1 here and then start searching for the minimum value. So now again we have found the minimum value here at 3, which is the index 2. So this becomes 2 here. Swap the values for index 2 and 1. So this here becomes again as 2, 3, 10, 8, 4 and 5 here. Done. So here we have 2 and 3 at the perfect position. So this is now called as the second pass. After the second pass we have two elements, the minimum two elements at the perfect position. Now repeat the same thing again here. The minimum index, the value for I, it now changes to 2. It is going to start from the second index, and minimum index is now 2 here. Okay. So now find the minimum value again. So this is going to change to 4, where we have the element 4. 4 is the index as well as 4 is the element. So swap these values again. So this again becomes 2, 3, 4, 8, 10 and 5. So we have the first three elements at the perfect position, and this is the third pass. Similarly, repeat everything again. So now the value of I is going to be 3, which is pointing out the element 8, and the minimum index will be here again as 3. Find the minimum value. Minimum value we have here is 5. So this index is going to change as 5 here, and then swap the values at the third index and the fifth index. So 8 and 5 has to be swapped now. So we have 2, 3, 4, 5, 10 and 8. So this is the fourth pass. We have the first 4 elements at the perfect position. Then the value of I now changes to 4, and then the minimum index, it will be now equal to 4. Now the minimum value, it is 8. Minimum value is 8, but the minimum index is 5, the last index. So index 5 and index 4, swap the values. So this becomes 2, 3, 4, 5, 8 and 10. Now this is the fifth pass, and here the first 5 elements is at the perfect position. Now do we have to repeat the same thing for the last element here? Now look here, what we said, the value of I is going to start from 0 and it will go up to L minus 2. What is the value for L here? The value for L here is 6. So 6 minus 2 becomes 4. So 0 to 4. So here we can see the value of I, the last value of I that we had, it is equal to 4. Why it is so? Because here you can see the first 5 elements, they are at the perfect position. So do we now have to look for the last element? No, it is not. Because the last number, it will automatically be at the perfect position. So we don't have to repeat this for another one more iteration. So this is it, how we are going to swap the values. Now in this situation, here we did not had any such condition that we have the I index and the minimum index same. Even in that condition also, we will write a generalized program in such a way that both values are going to be swapped. I and minimum index both are same, and even if it is swapped, it does not make a change. So we don't have to check another set of conditions for that. It will be working perfectly there. So that's it for today. This is how the selection sort algorithm works. Now, if you have any doubts, please give us a comment in the comment section. If you have any doubts, we'll definitely get back to you. And if you like the video, please press the like button, because this gives us a motivation to make more videos every day. And please don't forget to subscribe to our channel, and please press the bell icon so that you get a notification whenever we upload a new video. And keep watching to get the new video where we will be doing the implementation of the selection sort algorithm in C language. Thank you very much.